Hey guys, welcome back to Probability 7 now. And today we're going to talk about permutations. Okay, this is going to get into a little more complex things. This might be a 2-dayer, we'll see. I think as long as you watch the video, we'll be okay. But make sure you ask questions if you have them. And so we're going to talk about solving problems involving permutations. So let's first define permutations. It's a way in which a set or number of things can be ordered or arranged, basically. Just different ways you can arrange or order things, okay? So again, feel free to pause the video if you're writing that down. Everyone should be. So, an example. Let me get my pen out first. So, you have 8 students listed below. We have Alice, Bob, Charlie, David, Eve, Frank, George, and Horatio. Okay? We have 8 of them. I gave them all a number. And I have a gold, silver, and bronze medal. How many different ways can you give these medals out? And so the way we're going to think about it, let's just think about the gold medal, okay? If I just have one medal, how many different people could I give it to? Well, there's 8 people, right? So there's 8 different ways that I can distribute this gold medal. I can give it to Alice, Bob, Charlie, David, Eve, Frank, George, Horatio. Okay, so one of these people have a gold. So now, how many ways can I give out a silver? Well, if one person already has a gold, how many people are left to receive a silver? Well, that's 7. And then here we got bronze. If 2 people already have a medal, how many people are left that could possibly receive a medal? There's 6. So what we have to do is multiply this. So you do 8 times 7 times 6, and that equals 336. So there's 336 different ways you can hand out 3 medals to this group of 8 individuals, okay? And so every problem is going to consist of us drawing these blanks, so to speak, and you have to fill them in. Keep in mind, it wouldn't be 8 times 8 times 8, because if you give a gold medal to someone, one person already has a medal, they can't receive a gold and silver, so on and so forth. So a lot of these problems are just going to be very, very similar to this one, okay? Let me change my color real quick. What would be a good color? Color. Yellow maybe? Okay. And how many different ways can 7 different books be arranged on a shelf? Okay. So we have nice 7 books. 1, 2, 3, 4, 5, 6, 7. We have 7 different books. So let's say they're all taken off the shelf now and they're on our floor. And I have to choose which book goes into this first spot. So how many different books can I put in that first spot? Well, there's 7 books. So I put one of those books right there. Now I need to put a book in my second slot, which if one's already there, I only have 6 books remaining. So there's 6 possible books I could put there. Well, repeating, now I need to fill out my third slot. 2 are already taken, so there's only 5 left, and so on and so forth. And then we have to multiply. So we do 7 times 6 times 5 times 4 times 3 times 2 times 1, which equals 5,040 different ways. Okay, so that's permutation, sorry. Suppose the state requires a license plate to have 3 letters followed by 4 numbers. How many possible license plates are there? So again, we have 3 letters followed by 4 numbers. 1, 2, 3, 4. So we got our letters. We got our numbers. Well, let's think here. they don't say anything about they can't repeat, right? It just has to be 3 letters. So we have to think, how many letters are there? There's 26. So for my first 3 slots, how many numbers do I have possible? 26. Well, here they don't say we can't repeat numbers or letters. So I'm going to write 26 again. And then 26 here as well. Numbers, 0 through 9. How many values are there? Well, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options. So don't just say 9, because I know 9 minus 0 is 9, but there's actually 10 options because you could choose any digit from 0 to 9. So there's 10 options. So I could have any of those 10 numbers in this slot, in this slot, in this slot, and this slot. So we have 26 times 26 times 26 times 10 times 10 times 10 times 10. It's going to be a very large number. You get 1, 7, 5, 7, 6, 0, 0, 0, 0. So you get 175,760,000 possible license plates. Okay. And so it is important to note the story problem. Here, they didn't tell us that we couldn't repeat numbers or letters, so that changes things. Just like common sense, in this book here, you can't put one book in 7 different spots, right? You have to put a book here and then one of your other books there, so on and so forth. So we couldn't just say 7 times 7 times 7 times 7. The same with here. How many different ways can you give out medals, okay? So it is up to, there is some interpreting the problems. So let's go on to our next one. Computer password is to consist of 2 lowercase letters and 4 digits. How many possible passwords are there if repetition is allowed? So it's good that they said that. We can repeat our letters and numbers. So we got our letters and we got our numbers. So again, you have 26 letters and you have 2 of these, so you have 26 and 26 possible options. Then you have 4 digits. So again, there's 10 digits, 0 through 9. So this is almost the same as the last problem. So you do 26 times 26 times 10 times 10 times 10 times 10 equals 676. Oh, nope. Equals 6,760,000 passwords. Okay. Well, almost same problem. A computer password consists of 2 lowercase letters and 4 digits. So I'm going to draw out my 2 lowercase numbers or letters, A through Z, and then we have our 4 digits. 1, 2, 3, 4. Determine how many passwords are possible if repetition is not allowed. So again, good that they tell us that's not allowed. Well, let's look at our first letter. You have 26 total letters to choose from. So our first letter is 26 options, but then we choose one of them, and we can't choose that same one for this one. So we lost one option. So for this letter, there's only 25 options then. Okay? Because we used one for this first slot, so we can't use it for this one. Now same with the numbers. We said there's 10 total digits. Well, we used one of those digits here, so we can't use it for the next one because there's no repetition allowed. So now there's only 9 options. Well, again, now we're using a second digit here, so there's one less option for this one. So there's 8 options here. And we use 3 digits here, so that's 3 digits less options for this slot. So there would be 7 options there. So it would be 26 times 25 times 10 times 9 times 8 times 7. So 26 times 25, oh, calculator's messing up. 26 times 25 times 10 times 9 times 8 times 7 gets you 3276000. So that'd be 3,276,000 different passwords. And that's a lot less passwords just by not allowing repetition, right? So that's how you do it. You do have to pay attention to the story problem if repetition is allowed or not. So let's go on to another example. Suppose the state requires the license plate to have 3 letters A to Z and 4 numbers 0 to 9 with no repetition. Okay, no repetition again. How many possible license plates are there? Okay, so they don't tell us that the 3 letters have to come first, but that doesn't matter, right? Because we're just multiplying all of our values. So it doesn't matter which one comes first because 4 times 14 is the same as 14 times 4, right? We can rearrange the multiplication. And so I find it easiest just to write all of the letters first. So let's just do our letters first. Just group them based on what you can put in there. And then you have your numbers. And there's going to be 4 digits. Okay? Well, for the 3 letters, well, you have A through Z. You have 26 different choices. And then you have 25 different choices, right? Because there's no repetition, so you use one, and that's gone. Well, then you use another one, so this one's gone. Numbers, well, again, there's 10 digits. You're using one here, and so there's one less option for this guy. So you have 9. Well, there's one less there, so this should be 8, and this should be 7, right? So you have 26 times 25 times 24 times 10 times 9 times 8 times 7. And that gets you 78624,000. So that is 78,624,000 possible license plates. Okay? So it's all about interpreting the story problem, repetition or not. I always put these slots here. I think that's easiest. There are different ways to do these problems, but I think it's easiest just to write out these lines for our options and then fill in just how many options we have. Okay? So with that, try your homework. Hopefully it's okay. Make sure you ask questions if you have them. And I will see you guys tomorrow.